Welcome back to the 29th part of Debugging at Scale, where we decide on the way we want to fail. Fail fast means a system that would quickly fail in an unexpected condition. A fail-safe system will try to recover and proceed even with bad input. Historically, Java tries to take the fail-fast approach, whereas JavaScript leans a bit more toward the fail-safe approach. Note that this is a broad rule of thumb, and both approaches are taken within the respective ecosystem. A good example of fail-fast behavior would be the respective approaches to null handling. In Java, a null produces a null pointer exception, which fails instantly and clearly. JavaScript uses undefined, which can propagate through the system. It's hard to tell which one is better. There's very little research, and I can't think of a way to apply the scientific method objectively to measure this sort of methodology. It has both technical aspects and relates to core business decisions. Fail fast is typically easier to debug. A failure is immediate and usually obvious. A fail-safe implementation will be more robust and will survive in a hostile production environment like my kitchen. Companies using microservices are committed to some form of fail-safe. Resiliency is a common trait of microservices, and that is the definition of fail-safe. Modern approaches to fail-safe try to avoid some pitfalls of the approach by using thresholds to limit failure. A good example of this is a circuit breaker, both the physical one and software-based. A circuit breaker disconnects functionality that fails so it doesn't produce a cascading failure. Companies who pick the fail-fast approach take some risks but reap some big rewards. When you pick that approach, failure can be painful if a bug reaches production, but there are two significant advantages. It's easier to catch bugs in fail-fast systems during the development and debugging cycles. These bugs are easier to fix. The fail-fast approach handles such bugs better since there's a lower risk of cascading effect. A fail-safe environment can try to recover from an error and postpone it. As a result, the developer will see an error at a much later stage and might miss the root cause of the error. My bias is towards fail fast. I believe it makes systems more stable when we reach production. But this is anecdotal and very hard to prove empirically. I think a fail-fast system requires some appetite for risk, both from the engineering and from the executives, possibly more so from the executives. Notice that despite that opinion, it's sometimes smart to pick fail-safe. I have a kitchen appliance that picked the fail-safe approach. It's hardware running in an unknown and volatile environment. This means a fix in production would be nearly impossible and very expensive to deploy. Systems like that must survive the worst scenarios. Imagine failure in mission-critical systems of an airplane or a landing module. We need to learn from previous failure. Successful companies use both approaches, so it's very hard to pick the best approach universally. A more common strategy for handling failure is to combine the best of both worlds. A fail-fast when invoking local code or services, for instance, a DB. Notice that a DB might be in a separate container, but it's often near our actual service. Fail-safe when depending on remote resource, for instance, a remote web service. A remote web service can be in the same container, but it can be completely detached in a separate data center or managed by a different company altogether. The core assumption behind this direction is that we can control our local environment and test it well. Businesses can't rely on a random service in the cloud. They can build fault-tolerant systems by avoiding external risks, but taking the calculated risks of a fail-fast system. For any such strategy to work, we need to clearly outline these decisions on all levels. These decisions need to be present in the coding processes, code reviews, and in project management decisions. They should be enforced in tooling and tests. But first, we need to redefine failure, which is what we'll do in the next video. If you have any questions, please use the Slack channel to ask them. Thank you.